All right, let's jump right in. Today, we're going to peel back the layers on large language models and really get into how they think. You'll see that these systems aren't some kind of alien intelligence. Nope. They're actually a kind of silicon mirror, reflecting the very structure of our own minds. It's going to be a fascinating journey. I love this quote because it just cuts right through all the hype. We love to talk about AI in these mystical terms, right? Consciousness, a ghost in the machine. But the reality, well, the reality is a lot more physical. It's not magic, it's heat. The modern soul isn't hiding in some secret part of the chip. It's spread out across thousands of processors, guzzling megawatts of electricity, all to do one simple, relentless thing: predict the next word. And this is the absolute heart of the mystery, isn't it? How does a simple math equation end up writing a poem that can actually make you feel something? I mean, think about it. Under the hood, it's all just matrix multiplication. It's not feeling anything. So how on earth does cold, hard linear algebra manage to hallucinate love, or sadness, or beauty? That's what we're here to unpack. So here's the first big idea we need to wrap our heads around. This AI is not an alien. It's a mirror, a massive 175 billion parameter mirror that has been shown, well, basically everything humanity has ever bothered to write down. And each of those parameters, all 175 billion of them, are like tiny little knobs that the model tuned over and over again to create the sharpest possible reflection of us. This comparison to banking is a great way to think about the shift that's happening. You know, for all of human history, intelligence was tied to a physical thing, a squishy biological brain. It was a place you had to go to. But now, just like banking left the physical branch and became this invisible, frictionless layer in our lives, intelligence is doing the same thing. It's decoupling from biology and becoming a mathematical process in the cloud. Okay, so how does this whole process even get started? You can't just plug Shakespeare into a calculator. To do math on poetry, you first have to translate our messy, beautiful, fluid human language into the cold, hard, discrete language of numbers. And that translation starts with something called tokenization. Basically, an algorithm scours a massive amount of text to build a finite dictionary of the most common words and even parts of words. You end up with a vocabulary list of maybe 100,000 or so tokens. And just like that, a sentence like "the cat sat" stops being words and becomes a list of numbers, like, say, 464, 3795, 1209. But, a simple ID number doesn't tell you what a word means. That's where the next step, embeddings, comes in. And this is where it starts to feel like magic. Each of those number IDs is given a set of coordinates, a vector, that places it on a vast, high-dimensional map. And this isn't a random spot. It's a specific location in what you could call meaning space, where concepts that are similar are close to each other. And this right here, this famous example, just proves that the meaning map works. And get this, it's not a metaphor. It is literal vector arithmetic. You can take the coordinates for the word king, mathematically subtract the coordinates for man, then add the coordinates for woman, and the point you land on will be incredibly close to the coordinates for queen. Meaning, abstract human meaning, suddenly has a geometric shape you can calculate. It's just wild. So we have words as points on a map. Great. But language isn't just a jumble of words, right? It's about how they connect. It's about context. How does the model figure that out? Well, this was a huge problem for a long time, until a revolutionary breakthrough called the attention mechanism came along. The old way of doing things with models called RNNs was painfully slow. They had to read a sentence one word at a time, just like waiting in a long queue at the bank. And in a long sentence, it would often forget what the beginning was about by the time it got to the end. But transformers using attention are completely different. It's like every single teller window in the bank opens at once. Every word gets to look at every other word in the sentence simultaneously. This ancient metaphor of Indra's net is just a perfect way to visualize self-attention. Imagine every word in a sentence is a jewel, and every single jewel holds a perfect reflection of all the others. The word bank in the riverbank is no longer just bank in isolation. It's now reflecting river, and its meaning instantly shifts. It's this beautiful, holistic dance of reflections that creates context. Okay, so we've got the architecture, but when you first switch one of these models on, it's just a giant, chaotic mess of random numbers. It spits out pure gibberish. So how does it get from that chaos to coherence? Well, it learns. It learns through a relentless, brutal cycle of trial, error, and correction. You can really think of the training process as a simple three-act play. Act 1, the prediction. The model makes a wild guess about what the next word should be. Act 2, the judgment. It compares its guess to the right answer from its training data and calculates an error score, a single number that says exactly how wrong it was. And finally, Act 3, the correction. This is the magic of backpropagation. It traces the error backwards, figuring out which of its billions of knobs were responsible for the mistake, and nudges each one just a tiny bit in the right direction. And this is the crucial difference between how these models learn and how we often learn. A neural network has zero ego. Absolutely none. When it makes a mistake, it doesn't get defensive, it doesn't make excuses, it just humbly accepts the mathematical truth of its failure and updates itself. Now imagine repeating that cycle trillions of times. That's how you get from gibberish to genius. So now we've got this amazingly powerful, trained model. It's like a brilliant oracle, but it has one huge flaw. It's frozen in time. Its knowledge is completely cut off at the end of its training data. To make it truly useful in the real world, right now, we have to plug it in. We have to connect it to live information and give it the ability to take action. This is where you see two totally different kinds of knowledge come into play. The base LLM is like a mystic. It operates on intuition, on deep patterns it's learned. But sometimes, it just makes stuff up. We call that hallucination. On the other hand, you have a database which is like a scholar. It has verifiable external facts. The real magic happens when you bring them together. A technique called retrieval augmented generation, or RAG, basically forces the mystic to check the scholar's library before it's allowed to speak. It grounds the model in reality. And we can take this even further. We can turn the model from a passive oracle into an active agent that can actually do things. And it works through a simple but powerful loop called the react pattern. First, it thinks. It forms a plan. Then it acts. It calls a tool, like an API to check flight crisis. Finally, it observes. It sees the result of its action, and that new information feeds directly into its next thought. This is how a chatbot becomes a do-bot. All right, we're at the final piece of the architectural puzzle, the latest, biggest breakthrough. We've realized that building one single, gigantic, monolithic brain to do everything is actually incredibly inefficient. The future isn't one big brain, it's a collective of specialists. The old way, with models like GPT-3, was the monolith. Every single part of the massive network had to fire up for every single query, no matter how simple. Talk about a waste of energy. The new way is called a mixture of experts, or MO. Think of it like a council of specialists. You've got an expert for coding, another for creative writing, another for legal analysis. When your request comes in, a smart little router at the front door just sends it to the relevant expert. It's so much more efficient. And this ancient Persian myth is the absolute perfect metaphor for this new architecture. 30 birds go on a long, hard journey to find their great king, the Simorgh. When they finally arrive, they discover the truth. The term Simorgh in Persian literally means 30 birds. The king they were looking for was their own collective. And that's exactly how an MOE model works. The intelligence isn't in one single place. It's an emergent property of the group working together. So, after all this, where do we land? It seems we haven't built a god. We've built a mirror, the most powerful, high-fidelity mirror in human history. We took all our science, our poetry, our arguments, our code, our hopes, our biases, everything, and compressed it into this silicon matrix. So the next time you're staring at that blinking cursor, remember what you're really talking to. You're not waiting for an alien to speak. You're waiting to see a reflection of humanity. And the final most important question is this: do we like what we see?